This is chapter 5, volume, level 3 word problem, question 2, page, workbook page 160. We are looking at one of the last few questions we are going to try out for this chapter. By now, after solving quite a few volume word problems, I hope you discovered a certain pattern. Like most of the problems in this chapter seems to follow a certain storyline. So as long as you can read through the story, make sense of the story, the actions that is in the story, like pouring, before, after, you probably be able to tackle these problems quite confidently, as long as you remember and how the formulas and how you can put the numbers into the formula. Okay, let's take a read at this question. A rectangular tank measuring 28 centimeters by 20 centimeters by 15 centimeters was 4 feet full of water. Peter poured 2 liters of water into the tank and some water overflowed. Find the volume of water that overflowed. Give your answer in milliliters. Okay, for this time I read the question once and did not do the annotation with it because it seems quite complicated because this idea of overflowing. And the part about it that it wasn't completely full to begin with, it was 4 feet full of water. And then there's pouring action as well into the tank. So it sounds kind of complicated. So I am going to read it again as I do do the annotation this time. Okay, so hopefully that if you read it a few more times and you try to pick up the keywords, you'll be able to get the information and understand the story a bit better. So we have this tank here, a rectangular tank measuring 28 centimeter, that is the length. As usual, I'm using the highlighters to pick out the measurements, length, breadth and height. 15 centimeter. Okay, 4/5 full of water. This probably look like the 4/5 we were talking about. This may be 4/5 at first, 4/5 full at first. And to make sense of the stories, I am going to draw out the action. So there's pouring of water in. That's 2 liters into the tank. And what happened that the water overflow. And this amount of water that overflow is the question. You need to know, so how much is the overflow? And finally, the answers is requested to be in millimeters. So here the last part I put there as milliliters, very important unit. So there's some conversions necessary because you have centimeters as the measurements of the tank. Right, okay, so by now hope you have understood what's the story, what's happening here. So at first the tank wasn't full. Perhaps you just add a bit more water, that a bit is what 1/5, right? That is empty, this empty space here. Alright. However, Peter poured in more than that empty space could hold, and then end up water overflow. So the water that overflowed, it can't be 2 liters, it could be part of that 2 liters because it was the tank was not completely full. If the tank was completely full, then you pour in, then whatever that's flowing out is the 2 liters. So because it was partly empty, when you pour the water in, some of it will have occupied that space as empty. Alright, so in the end it overflow. So when we talk about overflow, there's this understanding. What do you mean by overflow? Overflow means it went over what the tank can hold. That means the amount of water was greater than its capacity. That's why it will overflow. Okay, so now we need to know the capacity then. How much water can the tank hold? Okay, so deal with this step by step. The first part is to understand the volume of the tank if it's full. This we are referring to capacity. That means how much water can the tank actually hold without spilling, overflowing. So the capacity we are looking at the length times breadth times height, and we are looking at the whole tank's height, that's 15 centimeter. So this will be a certain measurement. Now this measurement will be cubic centimeters. Now that's when it's full. So the first part is that we know that this is the tank's capacity when it's full, but the key part was at first it wasn't full. It was just 4/5 full. So I need to take find out that volume by using this times 4/5. So times that volume of the tank, which was 4/5 of its possible capacity, which is this number here. Okay, which you will calculate at the side. I could do 28 multiplied by 15 first, then after that the answer multiplied by 2 and then multiplied by 10. Then multiplied by 10. So I could do 15 by times 2. That sounds like a good idea. 15 times 2 is 15 times 2 is 30. So I could do 28 times 3, because you have 28 times 30 and then another 0, 300. So I could get this pretty quickly. Okay, so that's how I do the shortcuts to the multiplication. So I find the volume, which is this amount, okay, the capacity, the actual capacity of the tank. So 4/5, I know how much was it, okay, which is again another amount. Now at this stage I could actually look at this conversion as well. So let me work out this number. Perhaps it will be less confusing to see. So this amount was actually 8,400 cubic centimeters. Alright, so I could use at this point already convert the measurement to milliliters. Okay, which I already know that 1 liter equals to 1000 milliliter, and 1 milliliter is also equals to 1 cubic centimeter. So here I could write this and do the conversion to 8,400 milliliters. Okay, so I have to find out this amount, okay, which is you find this, and I can convert again to milliliters. Right, so that is the amount that it was at first full. Okay, then Peter add the pouring in. Okay, volume of water that is supposed to be in total before it went overflowing, it will be the 4/5 of the tank. That means I add the 4/5 of the tank plus the amount that Peter poured in. So which is this amount here, plus amount that poured in was 2 liters. So 2 liters will be 2000 milliliters. which will be this amount. Okay, so we know that the tank couldn't have hold this amount, so we're talking about the amount that spilled, that overflow. So the volume of the overflow water will be this amount here minus the capacity of the tank, what it can hold. Okay, so which here in this case, sorry for the handwriting, a bit of the scribbling. So this total volume that went in, that was we are hoping that the tank can hold, minus the capacity of the tank, that was 8,400 milliliters. So you do that subtraction, you'll be able to find the answer, which then again you'll be in the units milliliters. Okay, hope you can understand the flow of the story. Okay, we run through that again. So first I now understand what's the capacity of the tank. Then I find the amount of it at the start, that's 4/5, plus the amount that was poured in. So this is the amount that actually you want the tank to be holding. And then I use the final step. The final step is here, the volume of overflow is subtracting away what the tank can hold. So that would be the final answer. Remember, it's in milliliters. Okay.